Hello friends, today we will discuss about these two problems. Here you see, these two problems are similar to each other. This problem contains two energy sources. This problem also contains two energy sources. Here you have to calculate this branch current. Here you have to calculate this branch current. So both the problems are similar to each other. So what is the procedure to solve this type of problem? We have to know. In earlier class we have already discussed about KCL, KVL, Kirchhoff voltage law, Kirchhoff current law, Thevenin's theorem, Norton's theorem. But all these theorem, if you want to apply all these theorem to calculate this branch current, you cannot solve easily. So you have to know a theorem. By using this theorem, we can easily calculate this branch current or branch voltage, any branch current or branch voltage. What is this theorem? This theorem is superposition theorem. So we have to know about superposition theorem. By using this theorem, we can easily calculate any branch voltage or branch current when circuit contain more than one energy source. So what is the superposition theorem? Suppose this is a network. This is a network. This network must be a linear network. It should be a bilateral network. Bilateral network. So in this network, suppose you give the input, suppose x1, then its response or output is suppose y1. So when you give input x1, then its response is y1. Now if you give the input x2 in this network, x2, suppose this output is y2. Suppose this output is y2. Now if you want to give both the input x1 and x2 simultaneously in this network, so when you give both the input simultaneously in this network, then what will be the output of this network? So superposition theorem gives this idea what will be the output of this type of network when you apply more than one input. So according to superposition theorem, its output will be y1 plus y2. That means algebraic sum of y1 and y2. So what is the statement of this superposition theorem? The statement of the superposition theorem is, if a number of voltage or current source are acting in a linear bilateral network, then the current or voltage in any branch, is the algebraic sum of current or voltage due to individual energy source by replacing with their internal impedance. This is the statement. So what is this statement? The statement is, if a number of voltage or current source are acting in a linear bilateral network, then the resultant current or voltage in any branch is the algebraic sum of the current or voltage due to individual energy source by replacing with their internal impedance. Okay, this is the statement of this superposition theorem. So using this theorem we can easily solve this problem. So what is the procedure to solve this problem we will discuss here. So this is the problem 1. Problem 1, when you replace current source, then it will be open circuited because current source contain infinite resistance. When you replace voltage source, then it will be short circuited because voltage source contain small amount of resistance. Okay, so here this problem, so you have to calculate current due to 4 ampere current source, and here you have to calculate current due to this voltage source. So number 1, current due to 4 ampere current source. So when this circuit is redrawn, then what will be the circuit? This is 4 ampere current source, and this is resistance 2 ohm, and this is resistance 2 ohm, and this voltage source are short circuited. This voltage source is to be short circuited. This is be short circuited. Okay, because the internal resistance of this voltage source is very negligible, it's very small. So in this case, what will be the current of this branch? This is short circuited, so this current is divided through this resistance and through this resistance by using current division rule. So using current division rule, you can calculate I1. What will be the I1? I1 is 2 divided by 2 plus 2 into I, that means 4 ampere. So it will be 2 by 4 into 4 ampere, so it will be 2 ampere. So the current through this branch due to this current source is 2 ampere. Now you have to know what will be the current due to this 20 volt resistance. So number 2, so current due to 20 volt current source, okay, voltage source. So if you redraw this circuit, it will be, this is a current source, this is 2 ohm resistance, and this is 2 ohm resistance, and this is 20 volt, this is plus, this is minus 20 volt, and this is current source. That's why it should be open circuited, because current source contain infinite internal resistance. That's why it is open circuited. This is 2 ohm. So no current will pass through this branch because this is open circuited. So current through this resistance 2 ohm, it will be I2 will be 20 divided by 2 plus 2. So it will be 4. So it will be 5 ampere. Now using superposition theorem, so current I using superposition theorem, you can calculate I equals to I1 plus I2. So it will be 2 plus 5 equals to 7 ampere. So here the answer will be 7 ampere. So I will be 7 ampere. Now if you reverse this sign, if you give the minus sign here and plus sign here, then it will be minus 5 ampere. Okay, so due to this 4 ampere current source, there will be a 2 ampere current in this resistance. If you reverse this sign, then the current will pass through this 5 ampere. So if you take 2 ampere as a positive, then 5 ampere must be a negative. In that case, it will be minus 3 ampere. It will be minus 3 ampere. Okay, if you reverse this sign. Now second problem. So this is the procedure how to solve this type of problem. Now second problem. Here you see, you have to calculate current due to this 3 volt current voltage source. So current due to 3 volt voltage source. So you have to redraw this circuit. So this circuit will be, this is 3 volt plus minus, so it is 4 ohms, and this current source will be open circuited because current source contain infinite resistance, internal resistance. So here the current I1, suppose this is I1, so the I1 will be 3 divided by 4 ampere, because there will be no current pass through this branch, all current will pass through this 4 ohm resistance. So here is I1 equals 3 by 4 ampere, so it will be 0.75 ampere. Okay, so now current due to 0.25 ampere current source. So here this I1 is given, direction is given in this direction, and here is in this direction. So this current will be I1 plus 0.25 ampere, because current due to this current source. So if you redraw the circuit, so this circuit will be in this fashion. So this is current source 0.25 ampere, this is 4 ohm. So here it is short circuited, so current will pass through this junction, because this is 4 ohm resistance and here is no resistance. So current will pass through this resistance, no current will pass through this 4 ohm resistance. This current will totally pass through this resistance. So here this current is suppose I2, so I2 must be 0.25 ampere, because no current will pass through this 4 ohm resistance. because there is another path parallel to this 4 ohm resistance is resistanceless. Okay, that's why I2 is 0.25 ampere. Now using superposition theorem, you can say that I equals to I1 plus I2. So it will be 0.75 plus 0.25, so it will be 1 ampere. So current through this 3-volt energy source is 1 ampere. So in this way we can solve this type of problem using superposition theorem. In next class I will solve another 3 or 4 problem related to superposition theorem.